Good morning to Kaeva as the Assistant Laboratory Practicum Artificial Intelligence, and good morning to all of my friends. Let me introduce myself. My name is Muhammad Alif that you guys can call me Alif or Aam. And so today I'm going to give an explanation from my PPT is about the future of artificial intelligence. So let's we see. This is my present. Keep it, keep your eyes and ear, listen and enjoy. The future of AI. The future of artificial intelligence appears bright with continued advan advancements in technology. Investment in artificial intelligence reached to $93.5 billion in 2021, according to Statista. The current trend for neural networks to grow larger will likely continue to the near future as more functionality is required. The first topic is I'm going to be explaining about 3D computer vision. The first thing is the example of 3D computer vision is image processing. So, image processing is the process of transforming an image into a digital form and performing certain operations to get some useful information from it. The image processing system usually treats all images as two-dimensional signals when applying certain predetermined signal processing methods. There is types of image processing. There are five main types of image processing. The first is visualization. Visualization is finding objects that are not invisible. I'm sorry. The first is visualization. Find objects that are not visible in the image. The second is recognition. Recognition is distinguish or detect objects in the image. The third is sharpening and restoration. That is created an enhanced image from the original image. The fourth is pattern recognition. Is measure the various patterns around the object in the image. And the fifth is retrieval. It is browse and search images from a large database of digital images that are similar to the original image. The second example of 3D computer vision is programming. Artificial intelligence programming language, a computer language developed expressly for implementing artificial intelligence or AI research. In the course of their work on the logic theories and GPS, two early AI programs, Alan Newell and G. Clifford Shaw of the RAND Corporation and Herbert Simon of Carnegie Mellon University, developed their Information Processing Language, or IPL, a computer language tailored for AI programming. At the heart of IPL was a highly flexible data structure that they call a list. A list is simply an orderly sequence of items of data. Some or all of the items in a list may themselves be lists. This leads to richly branching structure. The third is about math, geometry, linear algebra, and optimization. Analytic geometry. Analytic geometry is a study in which we learn the data point positioning using an ordered pair of coordinates. This study is concerned with defining and representing geometrical shapes numerically and extracting numerical information from from the shapes, numerical definition, and representation. We project the data into the plane in in a simpler term, and we receive numerical information from there. Linear algebra. This is a branch of mathematics that concerns the study of the factor and certain rules to manipulate the factor. When we are formalizing intuitive concepts, the common approach is to construct a set of objects or symbols and a set of rules to manipulate these objects. This is what we knew as algebra. And the third is optimization. In the learning objective, training a machine learning model is all about finding a good set of parameters. What we consider good is determining by the objective function or the probabilistic models. This is what optimization algorithms are for. Given an objective, given an objective function, we try to find the best value. The second is about 3D. I'm sorry. The fourth is about 3D computer vision application. The first is augmented reality, or we can simply to AR. Augmented reality is a make-believe version or augmented of the physical world that is enabled through to the patronage of sensory stimuli such as sound and or digital visual elements. It uses such devices as smart glasses, smartphone, and tablets. Elements of augmented reality. The first is a combination of real and virtual worlds. The second is real-time interaction, and the third is accurate 3D registration of virtual and real objects. Computer vision has decrypted videos and images for a variety of applications such as character recognition. And through the devices, which are augmented reality enable have the capacity to build their artificial environment, which are in the long run coupled with the physical environment. The second thing is virtual reality. It's really more like it's similar to augmented reality, but reality is a digital technology that creates a simulated environment through sight and sound. Virtual reality is presented in a way that makes it real to the user. The three I's of virtual reality is interaction, immersion, and imagination. With the use of camera and sensor computer vision helps virtual reality to analyze a user environment and detect the location of its headset. Within the healthcare system, computer vision helps surgeons and precisely place surgical incision. It is also effective in the mental health system for the treatment of post-traumatic stress as well as depression and anxiety. And the third is visual mapping. Visual mapping is an image of an idea, a network of suggestion, an option that spreads out from an original word or phrase. Using main idea and then branching out into smaller, related topics allow people to see complex information in a better way, more comprehensive way. Rather than trolling back through roof notes and sentences, everything under your main idea is ordered in a much more structured way that allow you to retrace tangents and other idea without getting confused. The fourth is autonomous vehicle. Autonomous vehicle, or we can shorten it into AVS, use technology to partially or entirely replace the human driver in navigating a vehicle from a origin to a destination while avoiding road hazards and responding to traffic conditions. The, soci- the Society of Automotive Engineer or SAE has developed a widely adopted classification system with six levels based on the level of human intervention. The United States National Highway Traffic Safety Administration or NHTSA use this classification system. And the last is about 3D sensors. 3D sensors, we will talk about three types: Kinect, LiDAR, and radar. Kinect. Kinect is a technology that allows users to interact naturally with computer without using name controllers. In other words, the user can perform a operation using only hand movement. And I'm sorry, the user can perform a computer operation using only hand movement or other body movement. Kinect has features that include RGB camera, depth sensor or depth sensor, and multi-array microphone. Of these features, the depth sensor is a feature that plays a role in distinguishing Kinect from camera. Depth sensors are used to obtain data for an area in 3D regardless of the light condition in that area. The second is about LiDAR. LiDAR is also known as LiDAR, is an acronym for light detecting and ranging. LiDAR is a technology that implements an active sensory mode sensing system to determine the distance by firing a laser beam mounted on an aircraft vehicle. The distance is obtained by calculating the time between firing the laser beam from the sensor until it's received back by the sensor. Light detection and ranging or LiDAR technology has now been widely developed. LiDAR output is in the form of three-dimensional data with relatively high accuracy and faster data retrieval, making this technology widely applied in various fields. Thus, this technology can be used as an alternative to conventional mapping technology or terrestrial mapping. And the last is about radar. Radar sensors are conversion devices that transform microwave echo signals into electrical signals. They use wireless sensing technology to detect motion by figuring out the object position, shape, motion character, and motion trajectory. Unlike other sensors, radar sensors aren't affected by light and darkness, and with the ability to detect obstruction like glass, it can see through walls. When compared to the other sensor technology like ultrasound, radar can sense longer distance and is safe for people and animals. One of the biggest advantage radar sensor have over other sensor is its detection of motion and velocity. By detecting an object Doppler effect or change in wave frequency, a radar sensor can compute that object speed along with its direction. They can also observe that the target movement from different perspectives when using multi-channel sensors. Examining the movement from different perspectives in addition to previously collected measurements are used to determine complex movement. So, this is my research about the future of AI. There is nine website researching that I use for this material, and thank you very much. If there is some word that I mix mix speaking or miss explaining, or there is some word there is not really understanding. I'm so sorry, and thank you very much.